Originally developed for the Bristol Britannia airliner, the Bristol Siddeley Proteus gas turbine was notoriously difficult to start, plagued by compressor stalls and fireball-spewing hot starts. Engineers ultimately solved this using advanced hydraulic starters and automatic fuel drainage safety systems. Developed in World War II, Germany, this inverted V12 was an engineering marvel, but a nightmare to start. Oil constantly pooled in the downward-facing cylinders, risking catastrophic hydrolock, while severe bearing friction and lubrication failures routinely caused devastating engine fires during development. Forged in Yeovil, England, the Petter 14-horsepower S-type semi-diesel was a mechanical titan. Early engines couldn't achieve cold-starting diesel compression, so engineers solved this using a hot bulb. 10 agonizing minutes of blow lamp preheating before wrestling massive flywheels. Born from post-World War II efforts to upgrade American armor, the Continental AV-1790 was a mechanical beast. Starting this air-cooled V12 was an absolute nightmare, forcing engineers to solve critical cold start flooding, massive oil cooling demands, and complex magneto timing just to keep it running safely. Forged by French manufacturer SACM in the post-war industrial boom, the MGO V16 was a 16-cylinder powerhouse. Yet, starting it was a sheer engineering nightmare. Crews faced critical technical hurdles, combating severe cold start compression lock and mastering complex pre-lubrication sequences just to prevent the massive engine from tearing itself apart. Developed in 1956 by British manufacturer David Brown, this unconventional rear-mounted diesel solved crucial weight distribution and forward visibility problems for precision farming. Yet, cold starting it was an absolute ordeal, forcing operators to perfectly balance a decompressor valve while violently hand cranking the inertia starter. Caterpillar 3516 emerged in the 1980s as a heavy-duty industrial leviathan. Firing up this 69-liter colossus after a complete rebuild is a monumental task. Engineers must overcome immense rotational inertia, requiring intense pre-lubrication, massive starters, and flawless fuel priming. Born in the Cold War for British armor, the Rolls-Royce K60 was an opposed piston marvel. Starting, it was an absolute headache for engineers. Two-stroke scavenging meant it flat-out refused to run without a supercharger, requiring offset twin cranks to push exhaust out. Born in Bar-sur-Aube, the CERES two-cylinder two-stroke diesel was an industrial brute. Firing it up was a grueling ordeal, forcing engineers to solve critical challenges with inefficient scavenging loops and demanding preheating mechanisms just to achieve stable compression ignition. Originating from DEUTZ's legendary German heavy machinery lineage, waking this 16-cylinder behemoth was a monumental headache for engineers. They had to conquer sheer rotating mass and immense cylinder compression, manually priming critical fluids before its colossal turbos could finally spool up. Born in France by POYAUD, this industrial titan was engineered for relentless operation. Yet, getting it running was an absolute ordeal for engineers, requiring high-pressure pneumatic systems just to conquer the massive displacement and overcome brutal cold start friction problems. This mechanical titan came from 1950s France. Starting it was an absolute ordeal for operators, requiring a high-pressure compressed air system just to turn over the massive internals. Engineers had to master complex pneumatic valving simply to achieve initial combustion. Hailing from Mitsubishi Heavy Industries in Japan, waking this Leviathan was a monumental ordeal. Engineers battled the colossal cold cranking resistance of a 65-liter block, eventually solving it by sinking dual 7.5 kilowatt starter motors to shatter the engine's immense rotational inertia.